and then this would be C, and you would do that for this entire circle. Then you would do the smaller circle. You would also do the larger circle, right? So, a couple questions for you that I'm interested in. So, everybody probably should have seen that their pie, like here if we think of this as a pie, had close to 6 pieces, right? So, how many of you got exactly 6 pieces there? I got 1, 2, 3, 4, 5, 6. So we had 6 of you that had exactly 6 pieces. How many of you had 6 pieces and a little bit extra? Raise your hand if you had 6 pieces and a little bit extra. Kind of like I've got here. I had 3, 4 of you. Like that. Did anybody have less than 6 pieces? Or more than 6, like a whole, like 7 or more pieces? So we're all somewhere around 6, it seems. So, whenever you look at your angles here, if you got to measure your angles, that first, let's just see that first angle right there. Somebody tell me your angle measure that you got. But what did you get? 60. Okay. There's somebody else that has their angles. What? For the first, still for that first one. 54. Anybody else? For that first one. Anybody have more than 60? Everybody else somewhere in this range? Right. So the next one, Bo, what'd you get for the next one? Okay. Or you were one with the perfect ones, right? Okay. So, Matthew, what did you get for that second one? 113. So we can see his angles are a little bit smaller there, but we should see this pattern. Now, when you look at circle J and circle H, was there much difference between circle I, circle J, and circle H for your angles? You should see that they're pretty close to being the same. Maybe exactly the same, but pretty close to being the same. So all of these first angles should be somewhere around 55 to 60, right? Even if they're on the small circle or the big circle or the medium circle, right? So they should all be relatively close to the same. So down here where it says, what do you notice about the angle measures? What I was wanting you to notice is that the size of the circle doesn't matter. I don't know why this is not writing well today. My battery might be about to go out on this. Something's up. Or you could say something about the angles being the same. Okay, so the real question that so using this pattern right here to get to 180 degrees. So 180 degrees would be if we had a perfectly straight line here. All right. 180 degrees would be going from here. Sorry, my pen is going out. I think I need to change the batteries in it. So all the way around, or halfway around the circle, basically. About how many string lengths would that take? About 3, right? Depending on yours, you may have gotten exactly 3, or you may have gotten a little bit more than 3. Okay? Here, about 3. So Each length of the string is called a radian. Let's see if I got a battery. So, here's the question. Should it be exactly 6? Should it be more than 6? What should it be? Oh, wait, this picture. There's something you already know about circles that can help you answer this question. All right, what is that length all the way around the circle called? What do we call that? This is circumference. Let's see if this will work better now. Oh, yeah. All right, what's the formula for the circumference? It is not 2 pi r squared. 2 pi r squared is like putting both area and circumference together. It is 2 pi times the radius. Sometimes you may also see pi times diameter. But the one I really care about here is 2 pi times the radius. So circumference is the distance all the way around the circle. Right? That's what we're talking about here. How much it takes you to go all the way around the circle. Our string was the length of the radius. Right? So, for our circle to go all the way around the edge, it would be 2 pi times the radius, right? 2 pi, what is the decimal for 2 pi? 6.28 something, right? So, we should have gotten on our circles 6.28 lengths around, right? So if you got exactly 6, yours was off a little bit because obviously this was pretty inexact science here with taking that little string and measuring it and trying to go around the circle. So it should not be exactly 6 times around the circle. It should be a little more than 6 because it's 2 pi times the number of lengths of your radian. Right? So, radian measures can be used instead of degree angles. 2 pi is going to equal 360 degrees. So, 2 pi radians, I guess I should put, is going to equal 360 degrees. So, to make that even a little bit easier, 2 pi equals 360. So, what would just pi equal? 180. Because if we use pi and 180, they're a little bit easier to work with here. So, radian measures are a different way of measuring angles. So far, I believe you've only measured with degrees, maybe. Yes. Yeah, so it's probably just like a little bit difference in how you measured it. Yeah. So you probably were just a little bit off. So those first two were probably a little more accurate, right, than that. But if we could have done this perfectly, like we did on the computer or something, it would have came out exactly to be 2 pi for all of us. But of course, we didn't have those capabilities there. Yes. No, it's okay. You can leave it. Because this was sort of like an exploration to kind of see, because I did not really realize this until I went to a training for, like, after I was already a math teacher, and I had used radians a lot. I didn't really realize that that radian was the length of the radius around the circle. So it didn't make sense to me why it was 2 pi in that case. But 2 pi, if you think the circumference, that's all the way around the circle, much like 360 is all the way around the circle. Radians are used in a lot of, radians are sort of more a conceptual way to measure angles. We're going to learn several things where we can do a lot of things without a calculator with radians, where if we had degrees, we would need to calculate. Well, we can do either one, I guess. But everything on the AP Calculus exam is in radians. They do not put degrees on the exam at all. So while degrees are probably still going to be what you see more in a lot of lower level, like application sort of stuff, if you get into advanced math, they are going to use radians a lot of times for their angle measures. So you may dislike them at first, but there's something that's going to show back up in a lot of of the next math classes that you may take, if you take ones beyond this class. So what we need to learn how to do is convert degrees to radians. So 180 degrees is, like I said, pi radians. And that's what we're going to use for our conversion, that factor right there. So if I have 60 degrees, I could kind of do this in my head, right? 180 divided by what would give me 60? 3. So pi divided by 3 is going to equal these radians. So you can kind of do it in your head, but sometimes it's not that easy to do that in your head. So the other way that I want to teach you to figure this out, especially when we get down to like 15 degrees and 50 degrees, it's going to be much more difficult, is really just setting up a proportion. So I always know that pi equals 180 degrees. All right, so pi always equals 180 degrees. So that's going to be part of my proportion. We'll have pi and 180. It doesn't matter which one's on top, as long as your proportion is set up correctly. And so over here on the other side, I need radians on top and degrees on bottom. I know 30 degrees is going to be the angle that I have here, but I don't know the radian, so that's where I'm going to put an X. So to solve proportions, the quickest way to solve proportions is to cross multiply, right? So I'll have 180 times X equals 30 times pi. And then I'm trying to find that X, so I'm going to divide by 180. And 30 over 180 will reduce. It'll reduce to 3 over 18, and then that'll be 1 over 6. So I've got 1 pi over 6, which typically is going to be written like this, pi divided by 6. So that would be what we would have here. Okay. We can also do this in the opposite direction. So over here I've got radians, and I'm looking for degrees. So I can set it up the same. So I've got 4 pi over 3. I know that pi equals 180, so I can start from that. All right. And then I've got 4 pi over 3 radians on top, and then X for my degrees on bottom. And so to solve, I would cross multiply. I would have pi times X equals, I got to do 180 times 4/3 pi. I don't want you to multiply the pi in. Technically, you can. But let's just do 180 times 4/3, which is going to give me 240. So that's going to give me 240 times pi. All right, so when I'm doing that, I'm just doing, I'm doing 4 pi over 3 times 180 over 1. So I'm really just multiplying the 4/3 and the 180, or you could do, multiply straight across there. And then I got to get that x by itself. So here I need to divide by pi, which is just going to cancel the pi on both sides. So this would be 240 degrees. For all of these, I want you to do this without decimals, except for 13 and 14, because they have decimals in the problem. It's okay to give me decimals in the answer. So, like for 13, I know pi equals 180. So on the top, I would have radians, which is 3.5. And on the bottom, I don't know the degrees, so I'd put x. So I would have pi times x equals 180 times 3.5, which is going to give me 630. That does not have a pi with it, and I'm going to divide by pi. So x would be 360 over pi, but because our original had, 630 over pi, we're going to get 200.535 degrees. So it's really just setting up those proportions for all of these. So questions? All right, I want you guys to finish this. We're going to go into more with radian measures on Monday, and we're going to look at the unit circle, which is going to be something really important moving forward using radians. But today, I just want you to finish filling this out. You might be able to get it finished before you have to go, even though we only have like 5 minutes, I think. But that is